software, one of these pillars that I enforce a lot is testing. And I'm going to talk about testing strategies. Just to start with, let me introduce myself. My name is Ivan, and I am more known on the GitHub space. So I support many open source projects about clean architecture, test-driven development, domain-driven design, event sourcing. That is how I play around. After my day job, I usually code a little bit to improve my skills, trying out many different ways of writing software. But this talk is about testing. And to talk about testing, the first concept that come to mind is the famous test-driven development, which is known practice to guide the software implementation, where tests, when they are being written, they show the need of the software implementation that is required to make the test pass. So, and by doing that, the engineer, the developer, they communicate his intent to the code, to himself, or of what he's doing, and also it became a source of communication, especially when you have multiple engineers working on the same code base. So the tests show the intent of the software in a way that it's another way of understanding what's the purpose of that code base. Another characteristic of test-driven development is to boost the confidence of changing the software, like adding new features and having some assurance that the software won't break. And by having this confidence, you can also deploy the software more often. Because usually that's very common in many teams that, oh, we don't deploy on Fridays. But this is one reason to start testing the software, that you can deploy at any time, and that the test is showing you, well, everything is good. So at least it boosts your confidence, because you have lots of checks that show that, well, the software was implemented as it was supposed to. It doesn't completely solves environment problems, and that is another kind of tests. But anyway, the implementation, it shows that is correct. And the test-driven development has some rules that is nothing more than these 3 rules, that you are not allowed to. And first, the idea of TDD is you have unit test, which is test code, and you have production code, which is the code that is deployed and runs on the user machines or on the servers. And the idea is that you are not allowed to write production code unless there is a failing unit test. That then you are not allowed to write any more of a unit test than it's sufficient to fail. And also compilation failures are failures. So you can only write the test just a little bit. So it's kind of a ping pong, while you write the code on the test, and then you see that you need to catch up on the other side of the table on the production code. And then you go back and you write more of the test, and then go back to your production code. So it's this ping pong. And yeah, I would say that test-driven development became very famous on the extreme programming, and also from books from Clean Code, mostly from Robert Martin books that are quite famous in IT. And another way to explain the test-driven development, it's using the analogy of red, green, and refactor, where you write test and watch it fail, which make it red. Then you write just the enough code to make the test pass, to make it green. And while it is green, you improve the code without changing the behavior of the software itself. So it's the refactoring phase. But these rules are quite simple. They show some guidance, but I would say that the most common phrase is, I technically know what I'm allowed to do, but I have no clue what I should do. And just if you have the test-driven development rules in your mind, because they are the traction that moves you forward, but you need to have some like a direction to go. In this direction, it's something that we are going to talk about here. And when I start talking about testing, especially if you never done that before, there are some critics, and I understand the critics. Mostly when test-driven development is done incorrectly, it in some point make it worse. But not because of the test-driven development is doing worse, but the testing is being written incorrectly. One of the failures of tests are when the tests are so rigid. You have so much test code in a proportion to the production code that it's too coupled that you can't change the software anymore, because you have to fall back in refactoring a huge amount of tests. Another issue that happens when it is implemented incorrectly is you have slow tests. When you have tests that run lots of I/O, tests that are repetitive, that they overlap with each other, tests that fail due to side effects. In summary, testing the wrong things with the wrong approach. But we have ways to prevent that, and I would say that you can't put a rule in a company and say, we only follow TDD here. TDD is mostly something that you introduce in a company, and it is learned from the developers, and every interaction you make it better. So at some point you can use test-driven development. At some point you can have regression tests, different approach of tests, but always improving your testing skills. So just want to highlight that the separation between in the development, we have production code, which is used by customers and adds direct value to the product. So they make a feature available for the end customer, and that feature in some point brings value to the company. Another kind of artifact are the tests, which are usually used by the developers, and its value is hidden under this quality assurance. No user can give you a thumbs up because you have tests. But of course, if you don't test, maybe it will fail on the user and the whole experience, and trusting on your software goes away. And there is a challenge, because in the start of the project, you have a clean slate to write software, and I see that every engineer wants to write modular software that he can develop and test independently, that he can be confident about changing it. So we want to start the project and inch by inch develop a software that is modular. But well, as long as new features are added, new dependencies are added, we always shift the direction of the software into this big ball of mud, where I don't know, it happens that at the beginning we are fast adding new features and delivering software, and every new feature that is added, adding another feature becomes harder and harder, and you go to this direction of big ball of mud project, which adding new features, it's so slow that you feel like, oh, maybe I should start this project from scratch. I'm gonna talk about on the next slides. It's about the strategies of implementing software guided by tests in a way that it becomes more steady when adding new features. So the speed of delivering new features become steady. So the speed on the beginning of the project, it's quite similar on the when you are in the middle of the software and you have it in production. And to just simplify it, I have a typical software architecture, and this is, I would say, most business applications, how most business applications look like. So usually you have your front end with a fancy user interface. In this case, is a single page application, and it consumes a service that is this blue box that contains a specific structure where there are components that are more closer to the user, like receiving the requests. Then there are components that are more business focused, and other models that are responsible for interacting with external resources. So this typical project structure, and it can be reorganized or arranged internally in different ways, but mostly we have components that are interactors that receive requests, business code, I'm saying call it use case and domain, and this services and repositories that consume external resources. And to exemplify a little bit more, this application that I'm talking about here is a wallet application. It's an application that I have on my GitHub. It's called Clean Architecture Manga, which is my playground for software architecture and tech. And it contains these 5 use cases where a user can open an account, deposit some amount. It's kind of PayPal. You open an account, you deposit, and you withdraw, and you can transfer this amount in between accounts that you own. I would say that the logic about deposit, withdrawal, and transfer, the transaction management is the business logic. It's the core business of it. It's basically adding amount and subtracting amount and checking for the balance. On the other side, there are on the yellow side here components that, if you deposit 100 euros and your account is in dollars, maybe I have to apply an exchange service that change your amount from 100 to maybe $120. But the application itself do not know about the exchange service. It has to go to this exchange rates API that it's provided daily. Also, there is a persistence implementation that persists the transactions in the database and security. And all these yellow models are a kind of orthogonal to the software, because if they kind of grow independently of the business implementation. So maybe I have exchange rates in using a web service that runs that I have access, but maybe I have it in memory, or maybe I have my own exchange rate for my company itself, because maybe I'm not tied to the daily or to the live exchange service that exists. So the technology in yellow, they grow in a different speed and they change for different reasons than the business application, that the business in red here is kind of the core. And the user interface is just a way of interacting with this application, because I created versions of the software that is a console application that kinds of look like the software itself, but now I have a React front end for it. But how can I test it, and how can I grow the software guided by tests? For instance, how can I test a use case? Is this a unit test? Is this, can I test the withdrawal use case without considering that exchange rates API is available? Do I need database persistence to check my withdrawal use case? Well, let's see. But there are other kinds of models. How can I test my exchange rates API implementation without making a real call to the exchange rates API? probably I need to make this call, right? Otherwise, I'll never know if it is implemented correctly or not. So testing dependencies, I would say that is an integration test, needs to be done, but it's different than the deposit and withdrawal open account. So to explain it in more details, a unit test, there are some rules that I learned from the experiences that unit tests should not make extensive I/O. So that is the definition that I'm more familiar with, where unit tests do not make extensive I/O. So they don't go to the database, they don't go to external service in the cloud, and they target the entry points of your business logic. So, and that is one point that I learned after experimenting many ways. So, even though a developer can write a test for every single application, every single class that exists in your software, it is not ideal, because the unit test should be the user of the business logic. And the business logic usually have kind of entry points. And these entry points I'm calling use case, the features that are exposed by the applications. And the neighborhood elements, like value objects, you don't write tests specifically for them, because I think that the rule of thumb on the unit tests and production code is that test code should have its own project structure. We shouldn't mimic the production code structure into unit tests. But let's move on, because, and there is another fact that it's important to know, is that unit tests, they are really tight coupled to the software behavior. So if you change behavior of your software, you probably have to go back and change your tests. So this is a reality, but should not use extensive I/O. So a test will be much like it should have a setup project, a setup step, while the dependencies are being created, and any other neighborhood element is also being instantiated. And another thing is the suit part. Suit here means system under test is your target element. It should execute kind of in a single method, or in a very few steps, or I would say that it's on a single call. And the last part of the test is the asset, where the state and the side effects are being tested, validated, and checked. Now, as I said, application software, they need to consume external services. In this case, could be consuming a database or an external API. There is a misconception here that integration testing, let me test the whole software integrated in itself with all the moving parts. But what I learned is that integration test means test each single dependence separated, very clearly separated. Because what I want to know with integration test is it's kind of a checklist. If it used the database, okay, is the database implementation correctly implemented? Is the external API calls correctly implemented? Is the request and response correctly mapped? So the integration test, you can also include some contract tests. So in which the schema of this message are being validated, ensuring, so you have assurance that the implementation is correct. But it doesn't mean that you should test from the entry point of application, walk through the user interface, walk through the domain logic, and then make your final call to these external dependencies. No, that is not how it's supposed to do. You should test the integrations as a client of those integrations. So you develop those integrations in isolation almost. So one misconception is that integration test means test the whole software, but it's not. On my experience, the test is from the usage of those dependencies. Which means that the test, this is a test for the Exchange Service API, which means that it will make HTTP calls, it will go to your database. And that's the point when it is consuming I/O. So it is writing to the disk, reading from the disk, writing from the internet-work. So, which means that this kind of tests, they are exponentially slower than unit tests. In a way that you should have much less integration tests than unit tests. You have more. You have less power to do that, because every new test that you add, that is an integration test, is expensive to write, because usually it has side effects that you have to remove after, or to set up before running the tests. And they are slow to write, to run, expensive. Maybe every one of these calls can cost some money. So the attention point here is to not to reduce the overlapping of this call. So if I have a method that makes an external call, and another test makes exactly that call, you should prevent those redundant tests. And another characteristic of tests is testing the component in itself. So as a component, I'm talking about the models that are that are internal to the software. So without going to this yellow part, or without going to the database or external API here. I think I should have fade those elements, but to test the component test, it's only the internal part. And what you are answering, what the answer that you're looking for is to see if the models that are part of the component are wired up correctly. You also don't want them to make extensive I/O. So it's only the minimum I/O to see if the component can run. And any of these external dependencies, like the database or the external APIs, are mocked out in a way that you have in-memory components, implementations that gives you an illusion of these external services to exist. And by consequence, maybe you can't execute all of your use case because you have to set up all these dependencies to behave exactly how you expect. But so I would say that you also have less component tests. And so this is a characteristic because if setting up tests is costly, you should do them when they are available. So maybe you want to test if one single call for all of your use cases, but not a variety of requests for your use cases. So, which means here, I pointed out the Web Application Factory because it's one technique that I use to set up my tests and disable some features. And by disabling some features means that I replace the real SQL Server implementation with a fake implementation, the currency exchange service with a fake implementation of it. So I disable those features and replace them with in-memory. So this is one strategy that I use for component tests. And end-to-end tests are even more expensive to set up than component tests because they are actually going to the database, going to the external APIs, kind of checking if the components are, again, wired up correctly. So it's another answer that is given to you, but with the real implementations. So it will use extensive I/O. So it will go from the user interface to the database to the APIs. Again, the calls should be simplified because otherwise you have to set up all your databases with the state that you're expecting. So testing a variety is not the point here. And the difference here on this feature management is that the SQL Server feature is enabled and the currency exchange model is also enabled. And on this call, I'm not even asserting if the contract is correctly implemented because the contract I validated on the component tests part. So on the component tests, I had sessions for each of those properties that are required to be exposed and to be given back as a response. But on the end-to-end tests, I'm only interested, hey, can I make a call to the endpoint and it should return okay? and that is enough to give me confidence that at this point, I know that the unit tests were valid. The integration tests that communicate with database and APIs and all of those dependencies are individually tested. I know that the component tests show me that the application can run, can start, and the entrant test is showing me that all those models, and this is really the benefit of modular software, that they can work together. And so I took the freedom to say the criteria of how should I test, and I separated this unit test. Should I start, because when you're starting a new application, you have the different approaches of designing the software. I can writing the software from the business implementation. I can maybe write the software from the dependencies that is using externally. To decide that, I would say that if the use cases and the business logic are very complicated and you need to clarify it, well, you should start with the unit tests. If you are using a protocol or a technology that is critical and complex that you're not familiar with, I would say that write integration tests, testing specifically this technology implementation. So you'll say, okay, let me remove that from my shoulder and say, can I connect to this provider? If so, the integration test will answer for me. But maybe you want to develop the contracts and see, develop a contract that maybe will be shared with another team. So I would start with the component tests. But I would never start a software right entrant test, because it requires that the models exist. So I would never start with that. Some other rules of thumb is think about a session. It should be short. I would say that the only place that you can have a more extensive session is on the contract tests, on the I would say on the component test when your API is being validated against the request and response. The test has only one system under test, and I would say that there is a difference between mocks, which is this components that you define in the test setup that contains the expected behaviors, and the fakes that are similar to mocks, but they can run in production. So if the tests are costly and you can get some benefit of being able to deploy it to production, you are at least making the cost more effective, because you are putting test code in production, and in some point you can get feedback from the user from this test code running in production. So these are fake implementations. Highlight again that test first or test-driven development also do not mean that we write the complete test, then we write the code. it means much more write a little bit of the test, then write a piece of the production code, then write a little bit of the test, then write the code. So that is most of the ideas. And listen to the tests. If the tests are hard to write, slow to run, if they are too rigid to change, you should go back and refactor the test for if the setups are too long, too many sessions. So review the code and refactor it, because at the end of the day, the test is the tool that will give you some peace of mind, and that is I would mostly prefer to deploy my code and go back home and not to worry too much. And the test helped me into this habit, and I would recommend to all of developers to invest in that. Yes.
Well,
okay.
Thank you, Ivan.
Thank you.
Fantastic. Really good. I have found some questions from my side.
Of course, please.
Perhaps someone else also has something. I don't know, but when you do red-green testing, do you use any tool to speed up the process? Like I know it's in ReSharper right now, some kind of continuous testing. Do you use something like that, or?
I am mostly on the Microsoft stack, so ReSharper and Visual Studio it's a good partnership, even more because it has real-time tests running. It works very nicely for unit tests, so you even don't need to click on run to run it. So it's very very useful. But it's Visual Studio. The red-green part of it is Visual Studio, at least for me, and Visual Studio Code for, of course.
Cool. And then also, you talked about preventing redundant tests. Do you hunt redundant tests actively and remove them, or is it just a mindset when you go into testing?
It is. It's a way of organizing the project and the tests. I would say that if you organize your tests by first unit tests, integration tests, component tests, end-to-end tests, and have a clear picture of the surface of each of them, you at least removed the redundancy a lot. So this is they won't overlap too much. But of course, when writing integration tests, if you make a call to write to the database, read to the database, and write again, sometimes it's inevitable, and that is fine. But I think the redundancy that I'm highlighting more is it happens when you test code too further from your target. So you keep executing these long calls again and again until you reach your target point. I would say that just separating them by categories reduces the redundancy drastically.
Do you have how do you have the what's the word? I'm always too eager when I write code. That makes me. How do you keep a discipline writing a bit of test, a bit of code? Because I mean, it goes very, very fast, and then suddenly I sit there with my complete part and then write it.
First thing is, it is certain kind of tests are easier to follow that. For instance, testing business code is quite easy to write a piece of test and then a piece of code, production code. But so I think on that part is easier. It is harder. Let's say I have to consume a partner web service. I being honest, I mostly try the production code many times because it's dependent on the implementation too much. So when it depends too much on technology, I'm not too purist on that. Write a bit of code and write a production code. I'm purist on the business logic. That yes, but I think if there is a rule of thumb, is to learn the different ways of testing, so you have it on your toolbox, and then it became easier.
Without giving away any company secrets, how long is the test run at your place?
Yeah, I can talk about Clean Architecture Manga, which is a project that I support. It is 30 seconds. I would say that any project can be more complex or more simpler, but let's be realistic. The computer can run billions of mathematical calculations per second. So it is not supposed that our code that has ifs and else's and while loops to require billions of calculations and billions of seconds. So I would say that minutes it's okay.
Cool. Yeah, that is all that I have on my questions list. Anyone else has some questions? You got a couple of seconds more of silence.
Yeah, please let me.
Jocke, saying something?
We're a bit shy. I was gonna say that.
But please, we are at home.
If you're testing legacy code, I feel it's sometimes difficult to write good unit tests, and then maybe it's a bit. It feels like it's a bit easier to run end-to-end tests because maybe that's the only way to do it. How do you feel about that?
Yeah, but if the code is legacy and if it doesn't have tests, one way of improving it is before changing it, write a test, and in this case, it's kind of an end-to-end test that will show you how it works now currently. Yeah. So a legacy code, one way of changing it is to wrapping it into test, and after that, getting the confidence to actually change. And that is one lesson that I had. I had this Clean Architecture Manga project, and it is very purist, like all the patterns, everything decoupled. But the only way to achieve that is to have a test that gives me the ability to actively change it. So it started very bad at the beginning, because I was learning about clean architecture, and then I wrap it into a test, and then I could break it down, and I could say, oh, this works, so I can break it a little bit more. Then, so if you have legacy, wrap it, then you can change.
Yeah, but then so you have to have the discipline at first to write the test and then do the changes. So yeah.
Cool. Anyone else with something smart or less smart as my questions?
Okay.
If not,
okay.
If not, and if we're soon done here, let me see. Can I share do I share my screen?
Okay.
I want to give you thanks for coming to us and having this session. And as a thanks for that, we want to give a 500 kroner to some charity event. So you have the choice to support the rainforest or to support fugitives or to support children with cancer. So if you do your pick, I will send it to charity, and I will send you the diploma that you have supported something good with your talk, without not only supporting us, supporting everyone else too.
Yes, I really enjoy it. Doing these talks, it's really a pleasure, and I hope that we can make it a few more sessions. And I would say that definitely it's hard to pick, but the kids with cancer definitely would be my choice.
Cool. Then we will do this. Then we'll do it this time, and next time perhaps you will have less choices, and we will cover all the parts.
Yes.
Okay.
I'm very happy for that. It makes it more purposeful.
That's great.
Thank you. Thank you, Mans, again, and thank you all for joining us. And if you have more questions, just let me know on my email, ivan@paulovich.net, or on my GitHub. Usually, I accept many questions and issues there. So feel free to reach me out.
Thank you very much.
Yeah, thank you.
Thank you.
We're looking forward to the next session. Yeah.
Thank you. Have a nice evening. Oh, bye.
You too. Bye-bye.
Bye-bye.